And we have also seen or we have noted the transition from traditional code and fix model to and what are the limitations of code and fix model, which generally you use for the classroom, which is definitely not usable in the industrial environment. And so we have also discussed today's environment, where the primary concern is we have different sets of stakeholders. And I just repeat for 2 minutes. Unlike in code and fix environment, the way you do it in your classroom, you are the owner, you are the developer, you test your product and you use your product. On the other hand, in industrial environment, owner would be somebody, developer would be somebody else will test. So they all are different. And number two, today's environment is a group activity. Today's environment is a group activity. So you have to coordinate with the members within your group, and at the same time, you may have to coordinate with other groups as well. So what is needed for graduation from code and fix model to today's environment? We need to have some proper design. And another issue is, it's very common in the industries that the person who they leave the project in between, some new persons join, so that the design should be very well documented. As for example, when you build a house, building a house takes say 8 months, 10 months. If someone lives in between, nothing, there is no problem in carrying on with the development process of the house in according to the time schedule. So this, let's now get down to, yes. So what we are discussing today are very important from software engineering perspective, and these are very often asked questions in interview boards, in exams and everywhere, and you must have studied it in your regular course as well. So that led to the evolution of waterfall model. So what is it? First of all, this is the first time when development of software was considered as an engineering activity. Mind it, engineering activity. So what is typically, and what is the difference between an informal activity vis-a-vis an engineering activity? Think of some handmade, you must have seen many of your mothers, grandmothers, others, they handmade the clothes. But if you want to translate this process into a by manifold increase in productivity, you have to automate that. And how to automate that? The transition something like code and fix model here. Here, something like intuitive activity to every intermediate step and in unambiguous term. If any of you see the visit, say, the production unit of any automobile companies, say Maruti, Tata Motor, or if you see the production unit of any electronic goods, washing machine, TV, laptop, you will see that they all are produced out of a conveyor belt. That means the production process is actually classified, not classified, is divided into several steps. Divided into several steps. A part of the production is done in each step, and the output of one step goes to the input of the next step. So, first step starts with the raw materials, and then it goes to the second step, third step, and final step. The output of stage I goes to the input of stage I plus 1. That is a typically structured process for any engineering product. So here also, this is the first time. That's why this is considered to be a revolutionary idea in software engineering history. It was for the first time that software development process is structured as a cascade of phases. So what are those phases? Feasibility study, requirements analysis and specification, design and specification, coding and module testing, integration and system testing, delivery, maintenance. Now, at the beginning, I tell you that this is the concept. Depending on the book, depending on the literature, you may find differences in nomenclature of the phases. Number of phases might be different from one literature to another literature. But philosophically, this is what waterfall model means. We start with the feasibility study. Before we embark upon developing a product, first thing is we need to understand the feasibility. Feasibility has to be guaranteed. As for example, if you want to build a 10 stories building in a land which is not suitable to support 10-story building, there's no point in going for developing that. So similarly, feasibility study, first you have to understand. And remember, at the end of the day, management is also very important. And what are the management issues? Management of land, labor, capital, and technology. So all these are available or not, whether the product is feasible or not, that you have to take it first. Many companies are very well known for doing feasibility studies, like Pricewaterhouse, KPMG, then Deloitte, and all those. There are many other the very big companies. The reason is simple. What is the reason? Say, suppose a very big company, say Zomato. Now it has become a very big company. Of course, they already have, but suppose they want to develop a software product to support their business. Naturally, they have to ask for tender and receive tenders from various companies, and based on technical and financial viability, they will choose one. Now, writing the tender document itself is a hugely complex task. Writing the tender document. I have seen in many cases that at the end of the day, when we receive the tenders, there is a 5-fold difference between the lowest cost and the highest cost. Unbelievable. So lowest cost is probably 10 crore and the highest cost is 50 crores. And practically, if we are in the government sector, it's almost impossible to go beyond lowest cost, lowest bid. But probably in most of the cases, this happens because of inability to understand what is required. So that's why in the bidding process, most of the cases, at least in software cases, there are two-step process: technical viability and financial viability. So technical viability is done first, and then. So feasibility study has to be done very carefully. And another thing is there, the company which does the feasibility study comes up with the tender document, they cannot participate in the development process because that will lead to conflict of interest. The company which is floating the tender, they themselves cannot participate in the tendering process. So the traditional very big IT companies, they generally do not undertake the responsibility of uh, feasibility study or making pre-development activities because they are more interested in the development job and maintenance job, of course. Then comes requirement analysis and specification. In some literature, you will find it is divided into two steps: requirements analysis and then functional specification. Requirements analysis and then functional specification. Here I have clubbed them together, but there's no problem. You can divide it into two parts: requirements analysis and functional specification. What is the difference? Requirements analysis comes from the user perspective, and functional specification comes from the system perspective. User will give you the requirements. Say we need the system to support 1,000 users concurrently. Within 5 years, that may go up to 10,000 or 1 lakh users. Then this is the response time we expect. These are the functionalities we expect. On the other hand, functional specification means together with support or support to that requirements, they also have to identify the hardware and software necessary to support that set of requirements. So that's why systems analysts are so highly paid. This is the job of the systems analyst, that they interact with the users, try to understand the requirements, and be careful. The users need not necessarily be computer specialists. So they may not be knowing or understanding the intricacies of the computer. Similarly, the software specialist or system specialist, she may not be very conversant in the requirements in the domain where the software is supposed to act. If you are supposed to develop a banking reconciliation statement, think of yourself. How do you, to what extent you can know the intricacies of the domain? So it requires smartness, it requires very high IQ, and it most importantly, it requires sufficient amount of acumen to interact with the users. Interact with the users. This is very, very important. And in fact, in most of the cases, a questionnaire is also made to document the requirements. In fact, it is only after mutual agreement between the user and the developer, properly signed, that these are the expected outcome of the software. These are the expected outcome of the software. Then only the development team will take up the job. Otherwise, not. Be very careful. Users are never happy. They always keep on asking additional flexibilities. So, so this step, and in fact, there are many IEEE standards. I'm not getting into there to clearly document all these set of, have to take care of functional specifications as well. when you develop there are many non-functional requirements, like how are the GUIs you expect? What should be the font size? What should be the color? How many modules? Not exactly what are the functionalities. So both requirements and non-functional requirements. So now you have the functional specifications ready, for going ahead with the development process. Then you get into design and specification. You get into design part. I will explain design in further details, couple of talks down the line, because this itself is a very important topic in software engineering. And spec we have already mentioned, but I'm not going into again the details of IEEE standards and all those. So then you get into design. Remember, you are not supposed to get into coding at all before the design step is completely finalized and frozen. Typically in a software project development work, not more than 20% of the entire job in terms of time should be devoted on coding. In fact, it is going down day by day. Remember, if you think this software development activity should take 1 month, 20% of that means 6 days. Not more than 6 days you should reserve for coding. Now you understand the difference between how you what you do in this class and what is expected in the industry. You will have documentation, design, and so many activities, testing and all those. So then comes coding and module testing. And module testing means testing each module. Testing. I have already discussed probably the structured programming concept, when I said that the programmer must be disciplined in nature. So we expect the programmer will write whatever she writes in a structured language, structured format. That means a collection of modules. So module testing. Then comes integration and system testing. That means the modules have to be integrated with the system. Then comes delivery. And then comes maintenance. Here, delivery is a very critical issue. Delivery and deployment. Because most of the cases, the software is developed in the premises, not most, at least in some of the cases, is developed in the premises of the production house, not where the software has to be deployed for working. So the environment is very important. It's something like you are given the task of developing some agricultural activity, like very high quality apple. You do the all research and everything and get it developed in Kashmir. But you are supposed to do it in Kolkata or West Bengal. If the same process is replicated here, this will not work. Similarly, for software, it works in an environment. What is the operating system? What is the language? Of course, ideally, they have to be de-linked. But deployment is so important. That's why it is always said that when you port your product from the development house to the place where it is supposed to work, try to carry the entire environment as much as possible, like operating system, utilities, including the versions and all those. And then maintenance, probably no integration has to be tested. So since every phase has to be tested, there's no point in using testing as a separate phase. On the other hand, maintenance could be a separate phase. But now, in modern terminology, maintenance is also not used. The word used is evolution. Evolution. That's why the series of this talk is titled as Software Evolution. We do not say that software is maintained. Now, the question of maintenance comes only after it is deployed, naturally, and testing comes before the deployment. Obviously, testing is done before deployment. So we have the development, design, develop, all those, fully tested, deployed, it's working, and then the question of maintenance comes. Nowadays, maintenance is considered to be obsolete word. We use evolution. Why? Because we consider software evolves. How come it evolves? I had given you the example, and generally very often I use the example of railway reservation system, which was developed in early 80s, 40 years back. So by that time, whenever you make a software, you expect it to work at least for several years. And hardware and system software are definitely going to be obsolete within that time. So the software has to evolve. Software has to evolve together with the evolution of hardware and software. Today you have developed the software on some particular ways. Tomorrow the ways may change. You are using probably Java or Python. Tomorrow the language may change. The processor, memory, everything may change. So that is from the system perspective. From the requirements perspective also, the requirements may change. As for example, in the railway reservation system, I know very well, in the first version of the software, there was no scope. There was no scope for reserving any particular type of bath by choice. Like today, you can say that I want Elva bath. That provision was not there. That was included later on. So similarly, some facilities may have to be included. So that's why, depending on how the software is evolving, initially you start with version 1.0, then it could be 1.1 if the change is small. If the change is big, you call it 2.0. Similarly, 3.0, 4.0. So the term maintenance is replaced by the term this evolution. So this is typically waterfall model schematically. So this is called waterfall because The flow is like a waterfall. Flow is like a waterfall. Uh, but I'm repeating again and again, this is only a conceptual presentation. Depending on the book, depending on the literature, you may see the titles of the phases may vary, number of the phases may vary, but basic idea is just use the concept of some kind of conveyor belt based production development. Output of phase 1 becomes output of phase I becomes input to phase I plus 1. To the extent each of these have become such huge subject, like design itself is a huge subject. Today, instead of concentrating on some particular domain, you can consider just on one, say you become a design specialist. Huge job market is awaiting you. So the functional specifications, specialist in functional specifications. So that's huge. So what are the basic characteristics? So categorizes customers vis-a-vis developers. We have been saying this again and again. A software house develops customized software in response to a specific request to a customer who belongs to a different organization. Now remember, we have also mentioned the different categories of software. Say, when you develop a software like Oracle, software like Windows, software like Python, these are basically software products. General purpose products. And there, the developers have to come up with the requirements. You may not be knowing that Windows, prior to Windows, there was a operating system called DOS, disk operating system. Because that's the first time OS could be loaded in a disk. Before that, OS had to be loaded in the main memory. So, earliest version of Windows was nothing but DOS, only with kind of annotation. It's something like you have seen in many places. Say, when you drive a car, you will see hardly anything written anywhere. Everything is given by symbol. You know which place is reserved for not allowed, parking is not allowed. If you go to any hotel or any room, in many cases, you will not find the word restroom written anywhere. They will give the pictures. That's the only difference between DOS and Windows. And the market just accepted Windows like anything. So a software, so that is one kind of product. Then another kind of product which is more of a service. I told you I have given you the example of Zomato. Once the software is developed, that has to be maintained. So that is more of a service oriented. Like you develop a building, tomorrow some extension has to be done, repainting has to be done, something here and there has to be done. Similarly, you develop a software and then you keep on some maintenance job, but we call it evolutionary job. That is another thing. Third category is you develop some product which is essentially or completely for some particular domain. Nowadays, there's a huge demand for anything related to development of electric vehicles. If you are familiar with what's going on in the developed world, economically developed world, you will see that almost, I think, at least 40% of the researchers are working on something or other related to electric vehicle. Um, of course, electric vehicle will have very sophisticated software to run the vehicle. There are many companies. I can give you an example. KPIT Technologies, KPIT Technologies, Indian company. They are working on precisely just for the mostly for the this mm, development of software products for automobile industry. Automobile industry, expecting EV will be the next is coming soon, and within 1 year the stock price of KPIT has, I think, increased threefold, fourfold. Similarly, some industries are working on AI, ML based products for some particular domain. Today, education is one domain. There is some other domain. So you can have generalized products, you can have domain specific products, and you can have services. You can have services to address to. So all these are different kinds of software houses. So that's why when you prepare yourself for the interview of a particular software house, you must study what the software house is doing now. In fact, some software houses, they have both. So which job they are expecting to hire someone. And don't forget the basic 4 points I have mentioned right in the first class. I keep on maintaining that stand. First point is you must be very thorough in coding. And nowadays, generally Java, Python, these are very hot, but C, C++ is also okay. But if somebody asks you, what is your favorite subject? You should never say any language, because that is a language. You should be very thorough about it. That's true. Then you must be very thorough about the basic subjects, data structure, algorithms, architecture, and all those. If somebody asks you, what is your favorite subject? Don't use high sounding words like AI, ML, and all those. Politely, you say data structure, algorithms, DBMS, or computer architecture, computer networks, and all those. And prepare yourself accordingly. Number 3, behavioral issues. Behavioral issues. You should never be aggressive, but of course assertive. And be a very patient listener. When somebody is talking to you, never intercept the person. Let the person ask the question. Listen very carefully. If you don't understand, say, pardon me, but never try answering even before she asks the question. If you do not know the answer, there's nothing wrong in saying that you, I just can't answer these. instead of trying to, fool around the person. And number four, as I have mentioned, try to understand prior to facing the interview board the nature of the business of the software house, product, domain, general product, domain specific product, service industry, uh, and you make your presentation accordingly. Then a software development group develops customized software for other groups within the company. Yes, that's true. A software house develops a general application. That is fine. So I have already mentioned what is the waterfall model. Output deliverables of each stage must be standardized. Naturally, if it is not standardized, how can it be given to the next phase? I have given the example. When you manufacture bulbs, you must adhere to the standardized holder. You just cannot say that my bulb requires a special purpose holder. It will not work. Similarly, bolts, nuts, even as small as James clip, pin. So outputs or deliverables of each phase must be standardized. Methods for producing the desired outputs also needs to be standardized, naturally. Otherwise, how can we have the standardized product? Coherent framework leads to the formation of software development methodology. Yes. The precise definition of deliverables gives an unambiguous way of measuring the progress of the project. I've already mentioned that software development activity, it involves arts, science, technology, management, engineering, all facets. But the deliverables should be absolutely unambiguous. And now in waterfall model, the deliverables at each stage also should be unambiguously stated. So documentation, I have already told you the importance of documentation. Typically, thumb rule is if you write 100 lines of code, about 75, somebody says 70 to 80 lines should be on documentation. And documentation has to be intrinsic and at the same time extrinsic also. I've said intrinsic in the sense of coding. That means you should never use the variable names as I, J, K, X, L, etc. Each variable represents some physical entity. Name the variable accordingly. Name the variable as something like basic pay, DA, HRA. A roll number could be a variable. Marks could be a variable. So it should be intrinsic and at the same time it should be extrinsic in the sense we expect the coding has to be done in a structured manner. So it will have various modules. So each module must have proper documentation with it, saying that what is the purpose of that module, what it is supposed to do. Then comes verification, though named in separate box. Now, this is one of my very favorite chapters. I don't know whether I'll be having time to share with you some, at least one or two sessions on verification. But to start with, you must understand the difference between verification and validation. Verification and validation. Consider two questions. First question is, have you developed the right product? Or is it the right product? And the next question is the product right? The first question is it the right product? And the second question is the product right? These two are entirely different this to have entirely different connotations. Somebody has given you the job to develop a car for Calcutta roads. You just copy the design, development, and everything design, absolutely 100% of BMW, and develop a BMW in Kolkata. Is it the right product? Of course not. Of course not. There's nothing wrong in the product. There's nothing wrong in the product. But the problem is, this is not the right product for the purpose for which we need the product. You want to buy a TV. You buy a very big 60-inch TV for some house. And the house does not have any room more than 12 feet by 12 feet size. What do you do with that? Nothing wrong with the product. But the problem is, this is not the right product for the right job. Second question was, are you developing the product right? In my example, before buying the TV, you thoroughly try to understand the geography of the house, the requirements of the customers, and then buy a product, buy a TV to suit perfectly well with that ambience. Similarly, when you design a car for Calcutta, you survey the road, you survey how it works, you survey the kind of lawlessness in the roads. All these are there in the requirements, function specifications, and then you come up with the product. So that is where, is the product right means your specifications are very well given. Your job is supposed to develop a product which exactly matches with the specification. Whether it exactly matches with the specification. You are supposed to cook some food, same ingredients. If the customers are Indian, one preparation. If the customers are from Italy, another preparation. So, in software exact case, when we answer the question, is the product right? That means having given the specifications, you are supposed to develop the product exactly as per the specification. And that is the job of the programmer. That is the job of a programmer. To come up with codes so that the design specifications are perfectly matched. In the first case, are you developing the right product? That is the job of a systems manager, or in sometimes a systems analyst. If the user may not be familiar with everything, so if necessary, the manager and the systems analyst, they have to be humble enough and politely, if required, educate the customer about what are the things needed for the product to be a success for the job. So, if somebody says that, okay, the software doesn't work, what does it mean? At the programmer level, if she is convinced that it is as per the specifications, then this is not hard problem. You have given me the specifications, I have developed the project. At the systems manager level, the problem comes, then why did you sign it? I told you earlier that design, development, everything comes only after the agreement is signed by the customer and the developer. So if you know that this or sometimes it has to be documented. You tell the customer very precisely that yes, this is not the one which is going to serve your purpose. But even then, if she insists, the customer document it very explicitly and then say that I told you earlier. So these two are very, now generally what happens, we are living in a practical world. Say 3 of your friends, I had given you this example earlier also. 3 of your friends from the same class, very close friends, join the same company. Now, one takes up a marketing job, one takes up a development job, and the other takes up a testing job. The person who takes up the marketing job, her career growth depends on how much money he could, how many projects, how many big projects she could bring for the company. And sometimes it happens that they compromise with these philosophy. They try to grab whatever is available, not even fully knowing whether this is deliverable or not, or even if it's deliverable, whether it will serve the purpose or not. Now think of the development team. Development team will obviously try to develop the product in such a way that there is no error. What is the testing team? Testing team, their job is to find an error in the problem. So if the marketing people cannot get a job, cannot get a project, or cannot get the work, she loses her job. So she compromises with whatever. The person who is developing, even if she tries to develop it completely bug-free, the testing team will try to find some bug. If they cannot find any bug, they lose their job. If bug is found, then the development team lose their job. So all this is a very complex. Phenomena, and that's why organizational structure, behavioral analysis, all those are also very important. And remember, when you write a code for some module, you must ensure that this is bug-free right from the beginning. Why? If you find an error and then fix that error, there's no reason for you to be happy. There's no reason for you to be happy. You would be much happier if you cannot find an error. Why? It is obvious in a program, when you want to ensure that it is bug free, what you are searching for? Presence of a bug or absence of bug? Think very critically. Your goal is to search for absence of bug, not presence of bug. Suppose you have some 200 persons in front of you, a conglomerate, or 100 person. If somebody finds you, asks you, have you seen Mr. X? If you find Mr. X, you can say yes. If you cannot see Mr. X, can you say with that level of confidence that no, he is not there? So, finding presence of something is much simpler than finding absence of something or ensuring absence of something. And it is I can give you plenty of examples. One example, say you want to go for a long trip with your car. While you want to start the car, you see there's a problem. It's not taking the start. And then पीछे से धक्का मार के you just move. It's moving, no problem. So there was a problem and you sorted out the problem. Do you have the same level of confidence if the car did not have this problem to start with? Of course not. Of course not. It is sometimes said that in a code of large code, number of bugs yet to be found is proportional to the number of bugs already found. Again, appears funny. Number of bugs yet to be found is proportional to the number of bugs already found. You get a bug, identify a bug, fix it. It may lead to some other bug somewhere else. May not be in your module, maybe in some other module also. So, validation and verification, you should be very clear about the difference. And then management, a fundamental activity that shapes and monitors the entire development and maintenance process. Of course, so what is the basic takeaway of waterfall model? The software development process should be subject to discipline, planning, and management. Discipline, planning, and management. It was not there earlier. Earlier, it was something like somebody writing a poem. You don't know what she is thinking about. But of course, she may come up with a very good poetry. But that cannot be engineered. That cannot be mass produced. That cannot be sold in the open market. Then the implementation of the product should be postponed until after all the objectives of doing so are well understood. Yes. That's what I'm saying again and again. Implementation of the product has to be staggered as far as feasible. And it can be done only after the objective of doing so are well understood. So what are the concerns of waterfall model? Software development process is linear. So the results of each phase are frozen before proceeding to the next phase. That means you come to requirements only after feasibility study, come to functional specification only after requirements, then design, then. So it's a completely monolithic structure. Come to stage I+1 only after completion of stage I. And there is no scope for going backwards. There is no scope for rethinking. There is no scope for rethinking. So in some cases, it is proposed to allow some kind of feedback, but it becomes very risky because this very well defeats the very basic purpose for which waterfall model had been made. But it is also true that when you probably right at the design phase, you come to know that some specifications made earlier are not feasible. So, whether something done in a particular phase is correct or not sometimes becomes much more visible once you go to the next phase only. So it's kind of chicken and egg kind of problem. Whether you allow some kind of moving backwards as well. In pure waterfall model, there is no scope for moving backwards. But sometimes it is done, but remember, the moment you do it and you extrapolate it further, this basically becomes code and fix model. You do something, change it, do something, change it. So even if some kind of moving backwards is allowed, generally it is allowed only just up to one phase. Up to one phase. Another very important factor is there is no deliverable in the entire process of software development. Delivery is right at the end. It's something like saying that you have entrusted some builder to build your house, 50 lakhs. You have given him, you trust him, they're very good. But if they say that, sir, I will get the job done, do come after 1 year and I will hand over the house. But in the meantime, you do not know what's going on, how it is coming up, how it is shaping up. Just see how you will feel like. Similarly, in a software development also, if some customer gives some job to a software house, they would expect some intermediate deliveries. But then all these also have to be clearly specified. Specified at the beginning. But then waterfall model does not have any provision for this. How do you do it? Huge drawback. Another huge drawback here is, in today's world, customer is considered to be king. They can never be wrong. And customer generally wants to be involved in the development process. Think of the scenario. If you are a doctor today, the patient comes with so many inputs. सर हमें इंटरनेट में ऐसा देखा है, वहां पे ऐसा देखा है. So as if she is also a doctor. But in today's world, you cannot antagonize the customer. So you have to take the customer on board, knowing fully well. In most of the cases, they will provide nuisance values. But in some of the cases, they may give you some wonderful inputs also. But there's no denying the fact that customer has to be taken on board during the development process. And there's no scope for doing such thing in waterfall model. So in today's world, waterfall model has some serious limitations. So what are the concerns? Difficulty in accurate estimation of resources. Yes. User often does not know the exact requirement. That's what I'm saying. Sometimes user does not know the exact requirements. So they come to know only after certain stages. But waterfall model does not allow you to go back. And there is no intermediate delivery schedules. And anticipated waterfall model does not stress the need for anticipated changes, standards, and all those are there, right? Uh, but we have to accept that waterfall model is some kind of a pollster in software engineering. Why? This is the first formal approach to for translation of a and rather an informal software activity to evolution of software as an engineering discipline. So we started with what of code and fix model, which is not a model at all. We identified some limitations of that waterfall model, and then how come what of limitations of code and fix model, and then we discussed waterfall model, um, which is the de facto standard for many decades. And now, in the next talk, we will discuss spiral model, which is the de facto standard in today's world. Of course, they use waterfall model also. They use waterfall model also in between, in the process of developing, and this is known as SDLC, Software Development Life Cycle. Now, in waterfall model, there is no question of feedback, so the word cycle is not applicable. When you come down to the spiral model in the next talk, you will understand why it is called cycle. Software Development Life Cycle. Okay, any questions? Any questions? Are you still awake or sleeping?